Welcome pre-cal students to the homework help video. Here's the assignment right here. Let's go ahead and get started and help you with the ones that you have questions on, okay? Let's take a look at numbers 1 through 5, 1, 3, and 5. They want us to, if you look at the directions, they want us to match up the graph with the correct rational function. So let's go ahead and use our asymptotes to help us. First of all, vertical asymptotes. You take the denominator and you set it equal to 0 and you solve. So x squared minus 4 equals 0. I'm going to bring the 4 over and make it a positive 4 and then take the square root of both sides and I will get plus minus 2. So let's take a look. We know for sure we have vertical asymptotes going up and down at positive 2 and negative 2. Let's take a look at our options. Letter A is an option, letter C is an option, also letter E. So we have quite a few options, okay? So let's take a look at our horizontal asymptotes, okay? Whenever the degree up top, and by the way, we have x to the 0, even though you can't see it, whenever the degree up top is, let me write down our options. Let's see, we had vertical asymptotes going through 2 and negative 2 for graph A, graph C, graph E, and graph D. Now, whenever your degree is lower up top, you have a horizontal asymptote at 0. So let's see, we know we can get rid of B because you can't have a slant asymptote. Well, B was never one of them, so sorry about that. Let's see, could be A still. C is not going to be a possibility because C has a slant asymptote. Do you see that, guys? C has a slant asymptote, and so you can never have a slant asymptote and a horizontal. How do I know that? Because if the degree is higher in the numerator, you can't have a horizontal asymptote. You have a slant asymptote. So we know C is out of the question. Let's take a look at E. E is a possibility, and D is still a possibility. Now, actually, D's looking a little sketchy because I don't know if it has a slant asymptote or horizontal asymptote at 0 or not. So that one I'm not quite sure about. Now, one other thing I'm thinking here, if I put a 0 in for x real quick to find the y-intercept, put a 0 in for x, I would get 0 squared is 0 minus 4 is negative 4, 8 over negative 4 is negative 2. So let's see if one of these graphs has a y-intercept of negative 2. A y-intercept of negative 2. Well, A doesn't. A goes to the y-axis at 0. Or the A goes to the y-axis 0. E goes to the y-axis at 0. However, look at letter D. Letter D's graph is right here in front of you. And look at this. Notice how the graph goes through the y-axis right at negative 2, right there. Okay, so that's the one, letter D. Okay, let's continue on to number 3. Okay, first of all, we're going to find the vertical asymptotes. And this is the exact same denominator here as we had in back here in number 1. And so we know right away our vertical asymptotes are going to be x equals positive negative 2. Now, horizontal asymptote we know is going to be y equals 0. Okay? Because the degree up top, 1, is smaller than the degree in the bottom. All right? So we know we have this bit of information. Now, I believe that was what? We used D, so we're left with A, E, or D. A, E, or C. So A, C, or E are the ones we can choose from. Because how do you know that, Mr. Earhart? Because those are the only graphs that have vertical asymptotes at positive negative 2. D does, but we already used letter D. Now, we know we have to have a horizontal asymptote at 0, and that should get rid of C, because C has a slant asymptote. You can never have a slant asymptote with a horizontal asymptote. So now we're down to A or E. Well, let's real quick put a 0 in for x. That's always really easy to do. So put a 0 in for x here, put a 0 in here. 8 times 0 is 0. 0 squared minus 4 is negative 4. 0 over negative 4 is 0. So we should have a y-intercept at 0. So we go to A, and we have a y-intercept at 0. And we go to letter E, and we have a y-intercept of 0. So it looks like it could be either one of these, okay? Now, let me explain to you why your answer here, let me show you the answer. Let me explain to you why your answer, let me get rid of some of this math here, is the letter E and not the letter A. Let me explain to you why, okay? If you'll look at A goes like, I know I don't have A in front of you, but if you'll look at A has a part of a graph that goes like this. And it actually hits here and comes back down. And then look at the other graphs. They go like this. Now, students, you've got to get used to this, but if there is a horizontal asymptote at 0 right here, then these graphs here would come down and get closer to the x-axis, and they don't. They're up here going like this. And it looks like they're getting closer. If you look in your book at letter A, you'll see it. It looks like they're getting closer and closer to -8. There's a -8 here. So I would assume there's a horizontal asymptote at about -8 on this one. So A is definitely not your answer, okay? And now number 5, very quickly, your vertical asymptotes. Again, the denominator is the same. So your vertical asymptotes will be plus minus 2. Notice that we have, so now we're down to what? We just said it's E. So the only thing we're left with would be A and C, I believe. Yes, A and C are the last two graphs that have vertical asymptotes at positive -2 and have not been used yet, okay? So it's going to be one of these two. Now notice you have a degree of 3 and a degree of 2. Notice that 3 is exactly 1 more than 2. So that means you have a slant asymptote. Now which one of these problems, A or C, look in your books, which one of these problems has a slant asymptote, A or C? Well, if you'll look, C does. C has a slant asymptote right here, the dotted line right here. And so C has to be the graph that fits number 5. These were really good. 1, 3, and 5 were good thinking problems, okay? Let's take a look now at number 7, 9, 11, and 13. Determine the vertical asymptotes. Okay, no problem. Anytime I ask you to find the vertical asymptotes, you take the denominator, you set it equal to 0, and you solve. Take the square root of both sides, and you come up with x equals plus minus 0. And of course 0 is neither positive or negative, so your vertical asymptote is x equals 0. It's just that simple, okay? Let's move on to number 9. Okay, let's find the vertical asymptotes for this rational function. You always take the denominator and set it equal to 0. So 2 minus x equals 0. Bring this 2 over here. When you bring it over, it becomes a -2. So now we have negative x equals -2. There's really a -1 there, so we divide both sides by a -1 and we get x equals 2. So there you go. There's your vertical asymptote, x equals 2. Let's take a look at number 11. Okay, now this is really easy because look, they've already factored the denominator for you. So in order to find the vertical asymptotes for this rational function, you take your denominator, which I'm writing right now, and you set it equal to 0. Okay, and now you take each group and set each group equal to 0. If you do that correctly, one vertical asymptote would be 4, and the other vertical asymptote would be -60. So your vertical asymptotes are x equals 4 and x equals -6. Pretty simple. Okay, let's move on now to number 13. All right, let's go ahead and find the vertical asymptote. So we take our denominator and we set it equal to 0. Now, this is a quadratic, so we are going to try to factor. Notice we have a lead coefficient of 2, so we're going to take 2 times -3 and write our product way over here. 2 times -3 is -6. What two numbers would multiply together give you -6, but would add together give you a -1? Well, it would be -3 and -2. Now, students, we've done a million of these, so I'm going to go -3, +2. I'm going to go really fast. Okay, we should know how to factor this by now. So bring down your 2x squared. Put a -3x here, put a +2x here, bring down your -3, pull out what's common in the first two, that'd be an x, you're left with 2x minus 3, pull out what's common here, that would be a 1, and you're left with 2x minus 3. And now write your matching parentheses once, and you're left over with x plus 1. There we go. Not too bad. So now we take each group and set each group equal to 0. So if we do that correctly, this would be x equals 3 halves. And if we set this group equal to 0, it would be x equals negative 1. All right, so there we go. That's it. We found the vertical asymptotes for this function, okay? And then tomorrow we're going to get into graphing these, okay? All right, moving on to the next section, 15, 17, 19. They want us to find the horizontal asymptote. So remember how to do that. Whenever the degree matches the degree in the bottom, the top and the bottom, then the horizontal asymptote is lead coefficient, which is 3, over lead coefficient, which is 4. So your horizontal asymptote is y equals 3/4. Easy enough. You do that when the degree in the numerator matches the degree in the denominator. Okay, number 17. Whenever the degree in the numerator is smaller than the degree in the denominator, then you have a horizontal asymptote at y equals 0. Just like that. Okay, moving on. Number 19. Now, whenever the degree in the numerator is greater than the degree in the denominator, then you have what? No horizontal asymptote. There we go. Pretty simple, guys. Not too difficult. Okay, let's go on to numbers 21, 23, and 25. They want us to determine or find the oblique or slant asymptote. Okay, here we go. First of all, you might not have a slant asymptote. Let's check and see. The degree in the top must be exactly 1 more than the bottom. Well, that's the case. We have a degree of 2 here, a degree of 1 here. So the degree in the numerator is exactly 1 more than the denominator. So I can do long division, x plus 3 divided into x squared plus 4x minus 1. So x goes into x squared. X times x is x squared. X times 3 is 3x. Now we subtract. X minus x, they cancel out. 4 minus 3 leaves you with 1x. Bring down your negative 1. X goes into 1x one time. 1 times x is x, 1 times 3 is 3, and we really don't care what the remainder is. These cancel. 1 minus 3 is going to be negative 4, but once you have the remainder, that's fine. All that we care about is this part right here. So you take x plus 1, you set it equal to y, so y equals x plus 1. And if you were to graph that linear equation, you would have your slant asymptote. Okay, pretty easy. Let's move on to number 23. Okay, notice right here we have exactly 1 degree higher in the numerator than the denominator. So we're going to take x cubed plus 1 and we're going to divide it into the numerator, which is x to the 4th minus 2. So here we go. X cubed would go into x times x cubed is x to the 4th. Now be careful here. X times 1 is 1x. We don't want to put that right here because you're putting an x term under a constant term. So we're going to put our positive 1x over here. Now let's go ahead and subtract. We'll put a 0 here and a 0 here. X to the 4th minus x to the 4th cancels. Negative 2 minus 0 is negative 2. And then 0 minus 1 is negative 1x. 0 minus 1 is negative 1x. Now, I have taught you this. Whenever you're done subtracting, you always want this expression written in standard form, so the negative x should come first, okay? All right, here we go. Now divide first term into first term and hold it. I can't do that. You can't do it. Look, how can you divide x cubed into x? X isn't big enough. You can't divide 3x's into 1x. So this is your remainder. So you're done. Once you get to your remainder, you're done. So this is it. Your quotient is just x. So you take your quotient and you set it equal to y, and you get y equals x. And you can graph that. You could graph that. We'll get into that later, but you would graph that, and that would be your slant asymptote. Okay? One more problem, we're finished with the homework assignment. Okay, number 25. Okay, students, notice I have exactly 1 degree in the numerator higher than the denominator. So I'm going to do my long division. X squared plus 2x minus 1 divided into x cubed minus x squared plus x minus 4. Okay, here we go. Divide first term into first term. That would be x. X times x squared would give me x cubed. X times 2x would be a positive 2x squared, and x times negative 1 would be negative x. Now let's subtract. Watch your signs. X cubed minus x cubed cancels out. There's a negative 1 here. Negative 1 minus 2 would be a negative 3. And the positive 1 minus a negative, there's really a 1 here and a 1. So we have 1 minus a negative 1, that's a positive 1, so we get 2x. And then go ahead and bring down your negative 4 also. Now, is this written in standard form? Yes, it is, so we're good. We're going to move on. X squared goes into negative 3x squared, negative 3 times. Negative 3 times x squared is negative 3x squared. Negative 3 times 2x would be negative 6x. And negative 3 times negative 1 is a positive 3. Now, watch your signs. Negative 3 minus a negative 3 cancels out. 2 minus a negative 6 would be 8x. And then negative 4 minus 3 is negative 7. And look, you cannot divide x squared into 1x here, 8x. You can't do it. So this is your remainder right here. So this is your quotient up here, x minus 3. So you set that equal to y, and that will be your slant asymptote. Y equals x minus 3. Okay? So that's it. I hope this homework help video has been a help to you. Call or email if you have any questions.